Alright, let's take a look at this number 2 in the section on linear approximation and piecewise functions. And so number 2, they've given us this curve which I've graphed over here to your right, x cubed minus 8x squared plus 12x, and they want us to estimate it at x equals 2.9, and then they want us to estimate whether it's going to be higher or lower. Well, I went ahead and graphed it and then took a look at the graph and drew it a little closer here, and you'll notice that this red tangent line that's right here that I'm highlighting is shown here on the graph. And remember, since 2.9 is really close to 3, 3 is a great place to estimate it. It's a lot closer than 2 is. So if you look at this curve, and 2.9 is to the left of this 3 value, so just look at the function. The function itself happens to be increasing as I move back towards the left, back towards 2.99 or 2.9, and so our linear tangent line is lower than the curve. So we know that our estimate straight away is going to be lower. So we go ahead and answer that portion just by looking at the graph. So let's go ahead and take a look at a strategy we're going to use. We're going to use that linear approximation. So we're basically using the point slope formula. So we have y minus y1 equals m times x minus x1. And just to review you a little bit, our values y and y1 have to match up with that x and that x1. So what we're looking to solve for is the function value. So we're actually going to solve for this first y right here. So we have to have a numerical, we have to have a number for every term in that equation, that point slope formula, except for that y, because that's what we're going to solve for. So let's go ahead and take a look at what we can already know. Well, we already know the x and the x1 value. The x value is 2.9, and we're going to use x equals 3 as an estimation. So the next thing we need to look at before we even get started is what is the function value at 3. So you can plug in what we know. Well, the function value at 3 is just 3 cubed minus 8 times 3 squared plus 12 times 3. And let's just use our calculator for that. I already have this graph put into my calculator, so I'm just going to go right to the table. And at positive 3, the y value is negative 9. So let's go ahead and put that in there. We have y minus a negative 9 equals, okay, so let's take a look at what our slope is going to be. Our slope is going to be that tangent line at that 3, which is our derivative. So we can go ahead and write f prime of 3, and then our x value is going to be 2.9 minus our x1, which matches up with that negative 9 right there, is going to be 3. So cleaning this up, this becomes y plus 9 equals the derivative at 3 times that 2.9 minus 3. So let's go ahead and move everything over so we can just solve this when we're ready for it. So we're going to add it to this equation. 2.9 minus 3, of course, gives us a negative 0. Try that again. A negative 0.1. Okay, so all we need to do now is to find the derivative and then evaluate it at 3. So the derivative of this guy would be f prime of x is equal to 3x squared minus 16x plus 12, and that same derivative evaluated at 3 is going to be 3 times 3 squared minus 16 times 3 plus 12, and let's see, we have 9 times 3 is 27. 27 minus 48 plus 12. Adding those two together, we get 39 minus 48, and that would end up equaling negative 9, right? So there we have it, all the pieces that we need. So we're going to end up with y equals negative 9 plus negative 9 times a negative 0.1, and I believe that's going to end up giving us negative 8.1. And once again, it is an underestimation, and you can sort of analyze this because that's a pretty steep slope, right? A negative 9 is a pretty steep slope, so the curve is increasing pretty rapidly around positive 3 and around 2.9 as well. So it is an underestimation, and it's a pretty substantial underestimation, but good enough for our purposes here. Alright, I'll try another video, and good luck with this one.